Why do you say that you see the world? Maybe it's just an appearance. Even your thoughts are not decided by yourself. We think that everything works independently and has nothing to do with each other. But experiments tell us that the truth is far more outrageous than imagined. And reality may not exist as independently as we think. In this video, we will uncover the invisible connection. Go see what scientists have discovered. What kind of real world has it subverted? Before we start, let's do a little experiment. A physics experiment that will completely subvert your intuition. Imagine a picture like this. You are holding two coins in your hand, one in each hand. You throw them both at the same time and the magic result is they always fall on opposite sides. One positive and one negative, never an exception. What's even more bizarre is that the two coins are now separated by thousands of kilometers. You threw your one in Beijing. Your friend throws another one in Guangdong. The results are still positive and negative. There is no signaling or any covert communication. But it seems like there is a mysterious force connecting them. This is not science fiction, this is quantum entanglement. Back in time 1964. John Bell, a low-key physicist from North Ireland, wrote down a seemingly simple mathematical inequality. However, it is this inequality forever changed humanity's understanding of reality. Bell's theorem is more than just a cosmic challenge. It is a complete subversion. It's a testament to the world we live in. The rules followed are so strange and counterintuitive. Even Einstein called it ghostly action at a distance, and firmly believed that this can't be true. But the truth is that Einstein was wrong. Numerous experiments over the past 60 years have verified Bell's predictions. The results all lead to the same conclusion. There's a deep connection between the universe that goes beyond common sense. Particles far apart can interact with each other instantly. Not through signals, not through any of the forces we know. But a more mysterious connection. A connection that transcends time and space. Today we're going to delve into Bell's theorem. See how it reveals a surprising truth. That is, everything in the universe is without exception are fundamentally interconnected. This sounded like magic 100 years ago. But now it's changing the whole world. John Bell didn't originally want to revolutionize physics. He was in his office at CERN. Just a scientist who focuses on high-power quantum research. He is more concerned about experimental equipment, detection efficiency, and data output, rather than those abstract and mysterious quantum philosophical issues. However, the miracles of science often come from unexpected places. Sometimes questions that seem purely philosophical. Instead, it hides the truest and most justifiable answer. Bell ponders a story since 1935. Questions that trouble physicists. That year, Einstein and his colleagues Podolsky and Rosen published a paper that shocked the world. This is the thought experiment that came to be known as the EPR paradox. They think quantum physics is incomplete. It lacks some of the hidden deliberations that describe how the world works. Because according to quantum theory, two entangled particles, even if it is separated to two ends of the universe, measure one of them. The status of the other one will also be determined immediately. This deeply disturbed Einstein. He asked if anything could go faster than the speed of light. He cannot accept this kind of long-distance and timely response. So he suggested that quantum theory must be missing something. There must be some particles that we can't see. But the properties of the result have already been determined. This is the so-called hidden debate. In this way, seemingly instantaneous interaction. Actually, it's not super effective. Rather, the particles are already acting according to a certain script. Like two actors on stage. Seem to respond to each other. In fact, they are all acting out their earlier good lines. For the next 30 years, the debate continued. Einstein insisted on hiding the existence of deliberation. And proponents of quantum mechanics, represented by Niels Bohr, consider quantum theory complete. Those non-defining strange phenomena are not hallucinations, but real natural features. The problem is that both sides can explain the same experimental results. This brought the debate to an impasse. Until Bell appears. Bell realizes this is not just a disagreement between two interpretations. Rather, the two theories are making different predictions. If the predictions are different, that means it can be verified experimentally. Which one is the real world? Bell used mathematics to derive a surprising conclusion. If hidden debate really exists, then the correlation between particles must adhere to certain strict mathematical constraints. This restriction is called Bell's inequality, in the predictions of quantum mechanics, but exceeded this limit. In other words, if the experimental results violate Bell's inequality, that proves Einstein's hypothesis wrong. Is there really a connection in the universe that transcends time and space? Proof is one thing. Verification is another matter. Bell's theorem points out the direction for experiments. But to really verify it, experimental technology needed to be pushed to the limits of the time. You have to create pairs of entangled examples, measure their properties simultaneously, and make sure that the measurements are completed almost simultaneously. So fast that even the speed of light signal has no time to transmit the message. What's more difficult is, and maintain that fragile quantum state through it all. In the 1970s, Aurora is not mature yet. Detector efficiency is low. Computer formula systems are far inferior to today's. But scientists still decided to rise to the challenge. 1972. University of California, Berkeley. John Krauser and Stolt Friedman conducted the first truly meaningful Bell experiment. They cap atoms with excited states, create entangled photons, and measure the polarization direction of the photon. The results are shocking. Experimental data do violate Bell's inequality. Quantum mechanics wins. But science is the art of doubt. Someone pointed out, detectors may be biased. Maybe the method of measurement affects the results. Even the experimental device itself. There may also be subtle correlations hidden. These doubts are not just trivial matters. Because if Bell is right, then our understanding of reality will be completely subverted. The next few decades, scientists continue to improve experimental designs, improve detection efficiency, control variables, clean up vulnerabilities. Consistently experimental results both consistently violate Bell's inequality. By the 1980s, French physicist Alain Aspect made a key breakthrough. During his photon flight, dynamically switch measurement direction, completely plugged the so-called local loopholes. The result still violates Bell's inequality. But the problem is not over yet. At that time, the detection efficiency was still low. People doubt. Will the photon be detected? Just a few special samples. To end the argument completely, you must complete the vulnerability-free experiment. 2015. The scientific community has reached this moment. Multiple research teams completed successfully almost simultaneously. A truly loophole-free Bell experiment. They use efficient detectors, extremely accurate timing system, and controlled quantum particle circles. The final result shows nature does violate Bell's inequality, as quantum mechanics predicts. From then on, have fixed properties. Assumption that it can only affect nearby objects. Completely overthrown. The universe is announcing a fact to us. Reality is stranger than we imagine. Then the question comes. If quantum entanglement really transcends time and space, then our understanding of reality, should it also be completely rewritten? The answer is not to learn by doing, It is a physical test that can be verified experimentally. When we say that the universe is fundamentally are interconnected, we are not talking about some mysterious force or hidden energy field, but talking about a deeper, more precise phenomenon. Quantum entanglement can occur between particles, produce a kind of physics that far exceeds classical physics, a loud range of associations. But the wonderful thing is, it is not transmitted via any faster-than-light information. To achieve this, think about those two coins in front of you. If they were ordinary objects following classical laws, then the coordination between them must have limits, even if the most complex hidden instructions are written first. How related they are. It is also impossible to break through the boundaries of mathematics. Bell's theorem has strictly proved this. In any local area, in real-world model, no such correlation can exceed a certain value. However, quantum entangled particles, but they broke through these limitations time and time again. Sometimes it's even 40% stronger. This is not a difference in measurement, nor is it an experimental bias. Rather, it is the imprint of the quantum world itself. A clear signal. Tell us that the classical worldview is incomplete. Even more puzzling is, even though these connections are so strong, humans still cannot use entangled particles, achieve superlight communication. When you measure the particles in your hand, found that its self-selected direction is a homeopathic needle, you can tell immediately. The self-selection of the particle in the distance will be counterclockwise. But you have no control over the measurement results. All results are random, unpredictable. The experimenter in the distance also saw a string of random data. Only when you compare the records afterwards, only then will the precise correspondence become apparent. This phenomenon is called quantum information theory. Information seems to pass instantaneously between particles, but no usable information is actually transmitted. It's like the universe found a clever way. It breaks our intuition about locality. At the same time, it complies with the speed of light limit set by the theory of relativity. That connection does exist. It's just that it goes beyond the scope of cause and effect in our daily experience. The philosophical implications of it all are shocking. Bell's theorem forces mankind to make a compromise between two ancient beliefs. Either give up locality or give up reality. Most physicists have chosen to abandon the latter. They believe that before a particle is measured, there is no definite attribute. The measurement itself does not produce any superlight physical signals. Such an explanation retains the mathematical framework of relativity, and admitted that particle mechanics follows completely different principles. The universe has therefore become a strange stage, where the nature of things does not already exist. Rather, it is created at the moment it is measured. Reality is no longer revealed but generated. This view is counterintuitive, but it is a conclusion that has been continuously confirmed by countless precision experiments for decades. Of course, not everyone accepts this explanation. Some scientists believe that reality should be preserved. Acknowledge that the universe itself is non-local. Instant connections exist across any distance. It has also been suggested, every quantum measurement produces countless parallel results, existing in different branches of the multiverse. Some scholars believe that our understanding of locality and reality itself needs to be completely reshaped. Whichever explanation is chosen, one thing is certain: experimental fact before our eyes. Bell's theorem has been verified in hundreds of different experimental systems. Photon, electron, atom, ion, even tiny mechanical oscillators. As long as we are entangled, Bell's inequality will be violated. This effect is universal, stable, and repeatable, completely independent of specific experimental methods. What's even more exciting is, this quantum strangeness is already starting to change our world. quantum entanglement is no longer just a theoretical puzzle for physicists, and become a timely step in the new technological revolution. Quantum computing exploits entanglement effect for parallel computing. No more processing one bit at a time like a classical computer. Instead, it allows countless qubits to explore multiple computing paths at the same time. Thus, certain problems that cannot be solved by traditional calculations can be solved exponentially and quickly. This ability can be used to break encryption systems, simulate complex molecular reactions to help develop new drugs, designing efficient solar cells, and even exploring new materials to remove carbon dioxide. Quantum communication exploits entangled states. Establish an absolutely secure encryption mechanism. Any loss of information disrupts the system itself. Be noticed immediately. This is a security guaranteed by the laws of physics rather than mathematical assumptions. Now many countries have built quantum communication networks. China even launched a quantum satellite, distributing entangled photons across state distances. Europe is building quantum internet infrastructure. In the future, quantum computing and communication systems will be connected as a whole. Quantum sensors are also developing rapidly. They exploit the extreme sensitivity of entangled systems, can detect extremely weak magnetic field changes, gravitational disturbances, and even neural signals. These devices can be used to detect materials and monitor volcanic fire caves, observe cranial nerve discharges, even measure oil and gas reserves hidden underground or the magnetic signature of deep-sea submarines. However, perhaps the greatest impact of Bell's theorem. It's not about technology, it's about thinking. Experimental evidence of quantum entanglement forces humans to admit our intuition about reality is limited. The world doesn't work according to common sense. Logic shaped by our sensory experiences and evolution is not sufficient to describe the deep structure of the universe. This awakening has impacted philosophy, neuroscience, even research on consciousness. If the universe really operates on a level beyond space and time, so what does it mean to be conscious of self and existence? Some people speculate quantum effects may be involved in the brain's information integration process. Some people also think that quantum entanglement, it may explain the storage mechanism of black hole information, even maintains the consistency of the universe on a macroscopic scale, perhaps from the tiniest examples to the largest galaxies. Every structure of the universe echoes each other through quantum correlations. The story of Bell's theorem is ultimately a saga of mathematics and truth. That's just a neat mathematical inequality, but it revealed a reality beyond intuition. Just as Galen used mathematics to overthrow geocentrism, Bell used mathematics to tear apart the illusion of classical physics, showing mankind a subversive universe. Our Earth revolves around the sun, and Bell tells us, even reality itself may not be bound by space and time. This revolution is far from over. Bell's theorem was published only 60 years ago. It's been less than 10 years since the vulnerability-free experiment was completed. We are witnessing with our own eyes the very foundations of our understanding of the world being reshaped. Scientists normally entangle larger objects, make the entanglement last longer, span greater distances. Every breakthrough turns fantasy into reality. Next, lift the perspective from the experimental table. See how it enters life and nature. Scientists discovered quantum effects may not only exist in the particle world. It may have been exploited by life itself. Imagine when the back bird crosses thousands of miles and thousands of washes. Their sense of direction may not entirely rely on the fourth sense, but it comes from a strange quantum compass in the body. Research shows special protein in bird eyes. Earth's magnetic field may be sensed through quantum entanglement, thereby invisibly guiding their routes. What's even more surprising is Liangxiuju, this seemingly ordinary sense, It may also be using quantum mechanisms. Some scientists have proposed our nose, not just recognizing the shape of molecules. Rather, it is sensing the quantum vibrational state of molecules. This may explain why are two almost identical molecules, but it gives off a completely different smell. These studies mean those strange principles that Bell's theorem is all about. Not just an abstract concept in the laboratory, nor is it an exclusive tool for future technology, but maybe life. Core laws operating at the molecular level. In other words, evolution of life. Perhaps long before physicists discovered quantum mechanics, already have its secret. Quantum entanglement not only changes our understanding of life, it also shakes the foundation of scientific method. For hundreds of years, the way humans understand the world. It all starts with disassembly. We break complex systems into smaller parts. From atoms to molecules. From molecules to cells. To the standard model of particles. Such reductionism thinking makes science achieve brilliant achievements. But quantum entanglement tells us the world is more than this. In the quantum world, the nature of the whole cannot be simply derived from part. When particles are entangled, they form a holistic system. Any separate part cannot independently explain the overall behavior of. In other words, some truths must start from the whole, rather than relying solely on analyzing fragments. It's not just a matter of physics. It affects the way we understand all complex systems, such as climate change, economic fluctuations, even neural activity in the human brain. Perhaps they all depend on those invisible connections and coordination. The rules that really matter. Perhaps hidden in these subtle connections. Why Bell's theorem is shocking. It's because they are all related. Not accidental or error. It is a real physical connection. When two particles are entangled, they are no longer two independent individuals, but a unified quantum system. This discovery shatters our common sense about boundaries. In the classic world, stone and air are separate. People are independent. But at the quantum level, self and others, here and there may be no real boundaries. So new problems arise. Maybe the moment itself is a product of quantum entanglement. Perhaps it is the quantum correlations between the countless neural activities in the brain. Only then can we experience the unified self. In other words, maybe I'm not alone. Rather, it is a manifestation of countless connections in the entire quantum universe. Others have suggested quantum entanglement may explain cosmology's ultimate mystery. Why in the far corners of the universe, the laws of physics remain the same. Light has not had time to cross these distances since the Big Bang. How is information synchronized? Perhaps in the first moments of the universe's creation, those quantum connections disappear as soon as they appear, and continues to this day. Maintains the coordination and order of the entire universe. Although these speculations are still bold, but they demonstrate the power of thought brought about by Bell's theorem. Not only does it end a debate over quantum interpretation, it also opens up a new dimension of understanding reality. It tells us the universe is not an isolated fragment. It's a vast network of connections. What's even more exciting is, this exploration continues. Almost every few months, new experiments will refresh human understanding of quantum entanglement. Scientists have entangled objects visible to the naked eye, constructed a multi-example entangled network, even via fiber optic and satellite. Complete quantum transmission across hundreds of kilometers. Every breakthrough, all bring us one step closer to the future of quantum technology. It also allows us to feel more deeply the mystery and elegance of the universe. From Bell's neat inequality Quantum computing to today. Quantum communication. Humanity has witnessed the whole process of how an idea can change the world. It tells us, abstract mathematics can reveal truths invisible to the naked eye. Logical deduction can lead to a revolution in reality. What's more important? It reminds us, science is never just about accumulating facts or making tools. It is an exploration of the unknown. Questioning of existence. Bell's theorem: solid universe. It's a universe full of strange connections. Distant events can be instantly relevant. One measurement can affect results elsewhere. An observation itself determines what becomes real. For scientists of the past, it's almost like magic. But now we know. This magic follows precise mathematical rules. Can be predicted, verified, even used. Perhaps this is the deepest tragedy of modern physics. The more we understand the world, the more unfamiliar it becomes. However, precisely because of understanding these strange laws, we have the power to change the world. As quantum technology matures, humanity will continue to expand its cognitive horizons. Quantum computing may help us understand consciousness, design hard material, solving energy challenges. Quantum communications may usher in a new era of networking. Let information be transferred in an absolutely secure manner. Quantum sensors may even reveal the origin of the universe. Detecting dark matter. Observe the most dangerous process of life. But what is more important than technology is the awakening of ideas. Bell's theorem forces us to rethink the meaning of existence. If particles can be related without distance, if observation could create reality, so space, time, objectivity. These are the concepts we believe in most. Is it just an approximate fantasy? These questions may never have answers. But because of this, they form the forefront of human thought. That's where science meets philosophy. It is the boundary between mathematics and mystery. It's the moment when reason touches the unknown. Bell's theorem tells us, the universe is not an ordinary machine as described by classical physics. It's not pure chaos. It is a deeper order, where it is determined by random, local and non-local. Order and chance coexist. It is such a particle universe that we live in. A world where connection is the essence. This connection is not mechanical, nor is it a causal chain of phenomena. Rather, it is a connection between particles across time and space. It makes individuals no longer isolated. Make the universe a whole. Maybe isolation is the exception, and connection is the norm. From the neural network of the human brain to the Earth's ecosystem. From the cooperation of human society, structuring information networks into the digital age. All complex order. All come from those hidden connections and connections. Consciousness may be the highest form of this connection. It didn't originate from some neural park, but countless neural activities. Coordination and resonance at the micro level. Perhaps in the microstructure of brain cells. There are also weak particle effects lurking. It allows the mind to remember and perceive, condensed into what we experience. If particles are entangled, can make distant particles resonate instantly. Maybe it's a similar mechanism. Let scattered neural signals merge into unified consciousness. Bell's theorem ultimately tells us, the essence of the universe is connection. This sentence sounds simple, but like a mirror, what you see is not the outer sea of stars, but the inner self. If everything in the universe are fundamentally related to each other, so what are we? We are just intelligent creatures accidentally born on dust. Or are they the eyes that the universe uses to perceive itself? For thousands of years, human beings have been asking this question. Ancient people looked up at the stars. What I see is God in order. Scientist looks up at the stars. What you see are particles and equations. But maybe the two were never really separated. When we calculate the trajectory of a star, when we measure the self-suspension of a particle, when we write physical formulas, maybe the universe is passing through our thoughts. Reflect on yourself. We thought we were understanding the world. In fact, we are participating in the self-understanding of the universe. Science tells us quantum entanglement allows distant particles to resonate instantaneously. Philosophy tells us consciousness can experience the infinite in a finite brain. These two things may be different chapters of the same story. Just like the greed of particles requires observers, the meaning of the universe may require consciousness to complete. No consciousness. The equations of the universe are just cold symbols. And with consciousness, only then did they become perceived beings. We are not bystanders outside the universe, but the perceiver in the universe. Every time we think, exclamation every time, discovered every time, the universe is awakening through us. Think about it. After 100 years of evolution, the universe finally gave birth to a life. Can describe it in words. Express it mathematically. Reflect on it with thoughts. This may not be a coincidence, but inevitable. Just as particles are too determined in observation, the universe is also given meaning in the annotation of consciousness. The stars we see. Maybe it's the thought that the universe lights up for itself. Someone said, human beings are small, like cosmic dust. But from a particle perspective, dust is no different than galaxies. They all have the same particle wave function composition, all in the entangled network of the same universe. If the universe is a huge particle system, then our consciousness, maybe it's some kind of local interference pattern. Tiny but real. Short, but necessary. And when you take all this awareness, thought, dream, perceptions add up. The whole Earth, entire human civilization, perhaps it is a particle-level common evidence in itself. Internet, information flow, language and memory, entanglement between forward neurons. Let civilization form a new layer of consciousness. Maybe this is the universe. Self-organization in higher dimensions. It knows itself through life. Reflect on oneself through thoughts. And we are part of this awakening. If we talk about Bell's theorem, explains the interconnectedness of matter, then the consciousness is released. It is the interrelation of meanings. Entanglement between particles. It is a common proof of energy. Resonance between souls. It is the struggle of understanding. From a quantum level, these two connections. Maybe there is no fundamental difference. The universe is not made up of isolated individuals. Rather, it consists of countless interacting relationships. In other words, existence itself. Maybe it's a state of connection. Think about it. What does that mean? When you reach out and touch a stone, your fingertips, molecular, electronic, atomic orbits with that stone, are resonating silently through the quantum field. When you look at the starry sky in a daze, those photons from 10,000 light years away, passing through your retina, current with consciousness, the deepest entanglement occurs. At that moment, the boundary between you and the universe disappears. You are no longer an observer. You are the part of the universe that is observed. Universe. Look at yourself again. This is not metaphysics. Not a romantic fantasy. It is the inevitable conclusion of Bell's theorem pushed to the extreme. When everything is connected, observe and be observed. No more separation. Science and philosophy finally meet at the same point. That is, relationship is existence. It doesn't matter. There is no reality. And reality, it is the result of countless intertwined relationships. From this perspective, science is no longer just a tool for exploring the outside world. It becomes the language by which the universe understands itself. We thought we were studying galaxies, particle, gravitational waves, black hole. But every study, the universe is using us to rewrite its own story. Just as measurements in quantum experiments generate reality, human thought, it is also constantly generating the meaning of the universe. The universe is not only known to us, it is also realized by our cognition. So, the problem comes again. If consciousness is really part of the universe, can it in turn affect the universe? In other words, when we think about the universe, is the universe also changing due to our thinking? Maybe the answer is already written in quantum theory. When you measure a particle, its status is determined. When countless beings think about the universe, the meaning of the universe is determined. The end of science. Maybe not the answer. But to participate, we are not looking for the truth about the universe, but co-create the truth with it. This may be Bell's theorem, the ultimate inspiration for us. The universe is not an independent machine, but an ongoing conversation. We are not the audience, but the speaker. Every question, discovered every time, every thought. These are the pickups we left behind in this conversation. And it is these rebounds, constituting the consciousness of the universe. Imagine, when you gaze at the faint starlight in the night sky, that star may have gone out 10,000 years ago, but its light is falling on your pupils from now on. Its entanglement with consciousness. Let that long-lost star resurrect in your heart. This is the miracle of connection. Past and present, life and death, matter and thought. They all respond to each other on the same quantum web. So when we talk about Bell's theorem, we are also talking about ourselves. It not only tells us about the structure of the universe, reveals more about the way of existence, it makes us understand individual boundaries. Maybe it's just an illusion. Flow of time. It may just be a projection of higher order entanglement. Life is not wandering in the universe. Life is an expression of the universe itself. Consciousness is the universe thinking about itself. Looking back at the history of human science, from Galileo to Einstein, from Bell to today, every revolution, they are all wrapped up in the illusion of separation. Let's get closer to the ultimate truth. The universe is one. We are in it. When you realize this, science and religion, reason and mystery, micro and macro, no longer in opposition. They are just the same scene. Different parts of symphony, resonating with each other in infinite quantum harmonies. Every thought, every heartbeat, every beam of light, all part of that eternal symphony. Bell's theorem opens a door. That side of the door, not just a physical truth. There's also the meaning of existence. It allows us to see reality is not passively presented, but co-created. The universe is no longer a thing out there. It's a relationship that's happening. And you. We are all in this relationship. Maybe one day, when humans truly understand quantum connections, full meaning, we will redefine ourselves. At that time, the boundaries between science and consciousness will disappear. Human civilization will no longer be just civilization of observers, but the civilization of the participants. One co-evolves with the universe, a civilization awakening together. Then we might find the so-called secret of the universe. In fact, it has always been hidden in our own thinking. Because when we gaze at the stars, starry sky is also passing through our eyes. Staring at myself,